Okay. Module 2 quiz. Actually, I thought we could maybe do it together. I've opened up my chat on the screen here. So for those of you who are here, especially if you have not yet completed the quiz, I encourage you to put answers in the chat and we'll do this together. And if there's any questions, of course, we can chat about it as we go. Okay, let us get started. Oh, well, the first one I think I've already filled it in. But over here, the first one is saying, remember last time we learned how to create objects and then operate with those objects. So here we're creating an object called A and assigning it a value of 5. And here we're creating an object called B and assigning it a value of 7. And because these are both numeric objects, we're able to do A plus B because R recognizes them both as numbers. And then the answer is 12. That one's an easy one. What about this one? This one I want somebody in the chat to answer. So over here again, same as last time, we're creating an object called A and assigning it a value of 5. We have another object called B and we're assigning it a value of 7. And then C, instead of assigning it a number value, we are assigning it a text value, apple. So what would print out if I tried to run A plus C? So which of these do we think is the answer?
I think option A is the answer.
Let's try it. I think so too. Okay. Thank you. Okay, let's go next. Alrighty. Now we have what data type is C. So here we're creating an object called C and assigning it the value apple. So is this a numeric? Is somebody saying B? Fabulous. Okay, people are in agreement. Great. Okay, now question 4. What would print out if I run class A and class B? So remember, class usually shows you what the object class or type is. So it'll tell you if it's a number or a character or a logical. So what do we think class A and class B would print out in this case? Nice. I see people are commenting A. Cool. Oh, we have somebody on team B. A. Okay. We'll go majority wins, but then Simon, just keep your answer in mind when we check the answers. So over here, if you remember last time we were working with different object classes and we actually changed how objects were. We changed numbers to characters, we changed numbers to dates. So how can we change this to a date? Oh, nice, we have somebody saying C. Let's go with that, nice. Okay, question 6. What do you have to do to make sure that the command x plus w below doesn't result in an error? So over here, we're creating an object called x, and we're assigning it the value 3. And then we have w, and we're assigning it 5. But x plus w is going to result in an error if we don't change something. Okay, we have somebody saying D. Does anybody else have any ideas? D, okay, nice. Folks are in agreement. So somebody who's saying C, keep that in mind. We'll go with D since more people are saying that. But just keep C in mind. For here, question 7, what kind of data structure is object A? So it is a data frame, is it a vector, matrix, or an array? So I see somebody's typing B. Nice. We are in agreement. Okay, we're almost done. A matrix can have columns of multiple data types, while a data frame can only have columns of the same data type. Is that true or false? I see someone has typed B. Okay, let's go with that. Number 9, how would you turn these objects into a data frame? If someone was saying B, any other ideas? D? Okay, can you change your answer to D? Oh, over here we have more people saying B. Okay, we'll go with B since that's the majority. And over here, what would min A print? If you remember at the end of last session, we went over some commonly used functions. So if we have a vector A, min A would print, we say C. Okay, great. Let's finish quiz. Let's see how we did. Okay, we got almost every question correct. I'm going to say view questions to see. The first one was correct. The second one was correct as well. Third one's correct. Fourth also, I think somebody had said B here, but the fourth one, A, is correct because this one, if it's not in quotations, it's a numeric. And then if it's in quotations, it's a character. So that's why A is correct. So class of A is numeric and the class of B is character. Over here, this is correct. This is correct. I think somebody had said option C over here. Generally, the convention, if you want to change an object class or object type, you say as dot something. So you say as character, as date, as numeric. This usually changes an object. This is correct, vector. Also correct, false. Over here, D was the correct answer. So instead of data underscore frame, it's data dot frame. It's a very, very easy mistake to make because both of these are almost identical, but the function is data dot frame. And then the last one is correct. So everyone's did a really good job, actually. For those of you who have not yet attempted the quiz, I mean, you see it now, but if you haven't tried it, you will need to, I believe, score an 8 out of 10 in order to be able to access the next module. So similar to last time, module 3 will be available after today's session. And then the quiz will also be available. So you can attempt that. And, like always, we'll kind of go over the quiz in the following session to make sure everyone understands. So I'll pause there for a moment to see if anyone has any questions about the quiz or the module from last time before we move on. Oop, I see there's a hand raised. Okay, I think we've allowed you to talk, so should be able to unmute.
Good evening.
Good evening.
Okay, my question is while I was going through the module, the one on the group, I observed that for some of your comments, that when you do hashtag and you say something, you kept on writing hashtag in between, like for a particular sentence, you write hashtag, you start, and then you write hashtag in between. I was wondering, could one hashtag not be sufficient for everything you want to say? Why would you have to put hashtag in between?
Mm-hmm.
I don't know if you get my question.
I do. I see what you mean. So here you could, in theory, one hashtag is sufficient. So over here, I can kind of show you one hashtag. If I start writing like this, it's pretty sufficient, but you can imagine, I think maybe some of the newer versions of RStudio automatically wrap the text, but I have an older version, so it'll just keep going in one long line, which is why I kind of force, like whenever I see it running off of my screen, I'll force the next line and I'll add another hashtag, sort of force the next line and add another hashtag, like that. Does that answer your question?
I don't know if you could probably go to script 3 or script 4. Like, I get when you want to start a new sentence or when you want to go to the next line, but then in between the lines, like in between
Mm-hmm.
sentences at some points, you will actually put in hashtag, sometimes like hashtag W or something like that.
Mm-hmm. So that one, I think so these ones you see there's only one hashtag. So this is
Like for
automatically wrapped.
instance, where you are, there's a point you wrote hashtag factor object, and I'm wondering the hashtag that started that line, can't it be sufficient?
Yeah, so here, I think this is what you mean. This is a good example. So here I've added a hashtag kind of in the middle of a sentence. So over here, this is kind of, I guess, less coding dependent, more dependent on the sort of markdown language, if that makes sense. So in my R studio over here, if I don't put an extra hashtag, it just keeps on running and it goes across the page. We'll just assume my page is unlimited. So that's why I forced the hashtag, but there's some. So there's later on in these sessions, we're going to teach you about R Markdown. And R Markdown has a specific coding chunk, and in those coding chunks, it automatically wraps the text. So it works like a Word document almost. Once you reach the end of the page, instead of assuming it's a very, very long page, it'll automatically move your sentence to the next line, which is what is happening here. So over here, this is R Markdown in effect. So over here, you can see I only have one hashtag, but it has automatically moved to the next line. But because I wrote it in my R Studio, I kind of had these extra hashtags that I had to introduce, just so it stayed on one line for me. But that's maybe something we can modify on the back end of this module to make sure we don't have this happening. Because this is something that I just did for my computer, because of that unlimited width dilemma. But this is something
Okay.
we can change up, yeah. So it's not confusing,
Okay.
yeah.
Okay.
Problem.
Ashna, there's
Mhm.
a question in the chat from Simon.
Yes,
He's asking you run through the min A again.
yes. Ooh, we can. Oh wait, do I have to go through the quiz again? Or actually, maybe I can just run through min A on here. So I think the question went something like this. There was some vector we had created. 2, 3, 4, 5. We created some vector called A over here. And I see, oh yeah, Patrick has answered it. So the min function is just short for minimum. So if you put min A over here, it'll pick out the minimum value of this object A. And over here, the minimum value is 1. So it should print out 1. So if you remember last time we learned about this trick, so sometimes you have vectors where you have, oh wait, let me increase the size of this so it's easy to see. So sometimes you have vectors where you have, there's 1, 2, 3, 4, 5, but suppose the sixth value is a blank value or an NA. So if I say min B, it won't actually pick 1. It'll pick NA. There's a little trick we do to say min B NA remove equals true. And now it prints 1 again. So min just goes through and finds the smallest value. I see we might have another question. Oh, maybe it was a legacy hand.
I don't see any question or any hand raised.
No, I think it was just a fluke. But yeah, hopefully that answers your question, Simon. Cool. There are no other questions. I'll go on to this week's module. It's quite a simple module actually, but you'll see where we're going to do some review of last week while we're doing it. Here I won't go full screen so I can still see the chat. So over here, this week's module, we are talking predominantly about functions and packages. So similar to last week, I want to make folks aware of this online resource. A lot of the content of this week's module as well draws from this resource, and we definitely encourage people to check it out. So over here, I'm going to talk about functions and packages first. So this slide you should recognize from last week. This shows kind of what the structure of a function is. So functions are how you perform things in R. So it can be, so min was an example of a function. Same way on this slide, sqrt or square root is an example of a function. Typically you can tell something is a function because it's followed by these brackets. So similarly with min was followed by those brackets, the curvy brackets, not the square brackets. And whatever is inside those brackets is the input. And when you run that, it produces some sort of output. So in sort of data science speak, functions often ask for several inputs, and inputs are often called arguments. So you'll see that if you ever look at any online documentation about functions, it'll often call the inputs arguments. And it's quite rare for functions to just have one argument. Usually in R, you have several different arguments, and usually separate them by commas. So today we're going to take a look at how to use some of them. So functions are, you can imagine if you had millions of functions, things would get very, very cluttered. It'd be hard to find functions. It's quite rare that someone just knows what function to use. You often have to kind of Google and figure out what function works best. But luckily, R has a very, very handy way of organizing functions. So R puts these functions in folders, they call them packages, and packages contain functions. It's as simple as that. So when you first install R, you'll be able to see, so in your R Studio, you probably see there's a little thing here called packages. And even if you haven't installed any separately, R comes with a lot of packages over here. And it even tells you, gives you a little description. So over here, this package is used for some machine learning excitement. There's packages used for all sorts of different things, extra map databases, meta-analyses. You can see there's a whole bunch of different packages available. So the ones that are available as soon as you install R, these are called base packages. You'll often hear people referring to things, something called base R. Base R just refers to you coding using whatever packages are available as soon as you install R. So base R means I have not installed any special package. I'm just using whatever is available in R. And once a package is downloaded, it's stored in your library, and you can access functions that it contains in your current R session by loading that package. So it's a little bit confusing without practice. But you can think of R as a bookshelf or your personal library. So when you download a package, your bookshelf or your library gains a new book of functions. And each time you want to use a function in that book, you must borrow that book from your library. And your library is actually a folder on your computer, and it contains a folder for each package you have installed. And all of this sounds a little bit complicated, but we'll see how it works in action in a moment. There's a few different ways to install packages. Most often people install packages from this universe called CRAN. I forget what CRAN actually stands for, but it's a basically an area where all of these packages live online. And there's a few different ways of installing packages. We're going to teach you different ways. You can pick whichever one is your favorite. You'll see that I definitely have a favorite way. So that's what I end up using in my examples, but it does not necessarily have to be your preferred way. It's a thing in R in general that there are usually several different ways to do something. So it's good to learn different ways, and then you can kind of pick whatever works for you. So the sort of traditional way for installing a package uses this function called install that packages. So here you can install a single package. You have to make sure that whatever package you're installing is in quotes. You only need to install a package once. So once you've installed it, it'll now live here in your library. This over here is my library of packages. It even says system libraries. These are all the things that existed without me installing, and these are all the things that I installed on top of it. Oh yeah, Duncan, thank you. CRAN is Comprehensive R Archive Network. So once you've installed a package, it'll now live in your library. But every time you open up R, you're going to have to borrow a book. You're going to have to load that package for use if you actually want to use a function that lives within it. So you install once, but you load it every time you open up R. And there's a function to load a package. The function is called library. And note that I can only run this function after a package has been installed. So if I ran library tidyverse, but I had not installed it first, this function would tell me tidyverse not found. So I install it and then I load it for use. And just if you're paying attention over here, there are no quotation marks around tidyverse when you're loading. You only really need quotation marks when you're installing. That's one way to install and load. Another way over here is a very quick way. If you want to use a function, a single function within a package without having to load it. So this also requires that my function or my package is installed beforehand, but I don't need to load it. I can load and use them at the same time with the double colon. So what this does is it temporarily loads the package called read Excel, temporarily loads read Excel, and then accesses this function called read underscore XLSX within it. So over here, it's very, very good if you want to only use one function from a package or even two functions from a package, but you don't want to load it. You can kind of use it and load at the same time. So over here, we already showed you to check if package is installed and or loaded, you can view it in the packages pane. So this is over here, the packages pane. So if it's installed, it'll appear here. If it's loaded, it'll have a check mark beside it. And you can see, like, if I load this blob called library blob, now it's loaded. Or if I want to load whatever this package is, boot, library boot, it now has a check mark over here. So I can check which ones are installed versus loaded just by looking at my packages pane. So the other way, which I will preface is my favorite way to install and load packages, is through something called Pacman. So Pacman itself is a package, and it has this very convenient function called p underscore load. So what p underscore load does is it checks your packages library. It can install a package if needed. So if you want a package that doesn't exist in that library, it'll install it. And at the same time, it'll load it for use. And you can do it for multiple packages at once. If you remember in the previous slide, so install.packages, install a single package. So I can't use this, I can't do comma, another package in here, but over here, and this doesn't need quotation marks or anything, I can just list as many packages as I want. It'll install it if I don't already have it installed, and then it'll load it for use. So it's very handy because it saves a lot of time. So now I have a question for you that kind of draws from something we talked about last session as well. What if I want more information about a function? For example, let's use the function min, since we talked about min. Suppose I want to find out more about this function, what it does, how I use it. What's one way I can find out more information? You can either raise your hand or put it in the chat. And there are several correct answers here. There's a few different ways you can find out more information. Well, one way that Simon did over here, Simon asked, what's another way? We talked about last time where we said if someone says they're good at coding, they're actually good at something else. Simon saying Googling. Very nice. There you go. Yeah. Oh, and we have pieces also saying Googling. Yes, correct. You can Google, and that's exactly what we can do. Min in R. And something as simple as that, how to use min and max in R over here. I'm going to decline all. Okay. And it even pulled up a little helpful page over here that gives me examples of how to use min and max. Tells me a little bit more about it. Returns the minimum value present in the vector. So Googling is actually very underrated. Googling is the way to code. And actually, I know Frank said we would experiment with ChatGPT. We'll see at the end of this session as well. We can maybe experiment with ChatGPT as well, because that has become, I know people say it's cheating, but it's actually a really, really handy way to start code. So if you don't know where to start, ChatGPT is a really good way to kind of help you start, and then you can kind of build your code from there. Another way, instead of Googling, is also this handy help pane over here. So if I search min in here, it'll print out a help page for it. And the help page usually also has details of the function, notes, references, and the best part of the example. This is what is quite helpful over here. So use the help pane as well. I believe there's also a way to do it. If I say question mark min, it'll open up the help page. That's a little shortcut. Or question mark min, it'll pull up the help page for me. Of note, there is, I believe, a single question mark can be used to pull up the help page of a package that has been installed and loaded. But suppose I want to find out some more information about, let's say, have I loaded tidyverse? No. Okay, so you can see tidyverse is a package over here that I have installed because it exists over here, but I have not loaded. It doesn't have a check mark here. And if I want to know about a function that exists within tidyverse, let's say group by, it's going to say no documentation for group by, but if I say question mark group by, now it'll pull up some helpful things, dplyr group by. So over here, I had to use two question marks because I had not yet loaded that package, but it was still, the two question marks looked amongst all of my installed packages and looked up the help pages for that. These are also handy ways to look up information. And to test those, we're going to take the next few minutes and actually give you a little task. Ooh, Duncan's also saying, while Googling, also narrow down to the R communities that are there. There also exists R documentation. Yes. So this R documentation link that Duncan has shared over here is really, really helpful link and has lots of good help pages. Stack Overflow is also very commonly featured. But the more you Google, the more you'll see there are very common communities that are there. And the more common they are, often the more trustworthy they are. So these are usually very trustworthy links that work. So thank you, Duncan. So I'm going to give folks a task over here. So Googling is also an art. So sometimes you can try to Google something, but you end up finding things that are unhelpful and that don't give you the right answer. You often have to ask the question very strategically. So I'm going to ask you to do that for now. So you can pick one of the three things on here. So these are all tasks that are possible to do in R. You can import a CSV file into RStudio. You can create a histogram in R. You can actually even compose a song in R. So I want you to Google and either raise your hand or put a link in the chat that helps you do one of these tasks. So I'll pause there for a couple of minutes and let you Google and see, just let me know what you find for one of these three. You can pick whichever one you'd like. We found a link to our music. So over here, you can see this, I presumably was for the third one, using R to compose a song. Nice. Simon found a link to histograms in R. Okay. Oh, very nice. And there are some examples also. Cool. Nice. So several different packages you can use to produce music with R, should any of you wish for a music production career. Did anyone manage to find, what was the other one? Importing a CSV file. That one's jumping over. I think the next module you'll actually learn how to import and export things. Importing a CSV file into R. There we go. We have lots. Data Camp, this is another very trusted website. It often gives tutorials. I don't know if all of them are free. Yeah, some of them are. How to import data in R, a tutorial. Please don't, if there's a tutorial, it's usually quite helpful because kind of constructed with examples and different, I guess, examples of different kinds. So, and they usually explain it quite well. But good job, yeah. I think people probably get the idea over here. So feel free after the session, if you didn't get a chance to check one of these out, feel free to Google it and see how R can be used to do all of these things. It just goes to show how many things can be done in R. So over here, I've made a list, and you'll see this once we release the module online for today, module 3. This is all included in there as well, so you don't have to worry about noting this down. But these are some helpful packages for health research specifically. These are ones that are used quite often by academics, those using healthcare data. Of course, there are a lot more than these, but we've made a little short list so that you kind of know what could be helpful. And you'll see we'll try to use a lot of these in the upcoming module that will go over things like importing and exporting, that'll go over how to make tables and figures. Once we start getting to more complicated tasks, you'll actually start recognizing these, but I wanted to introduce them today so that you do kind of remember when you learn about them, you'll recall, and it helps you kind of remember what each of them is for. So tidyverse, you already saw me use it once. Keep it in mind, tidyverse is like the mother of packages. Actually, tidyverse is a collection of packages, very, very handy for data cleaning and analysis. It also includes packages that help manipulate data and visualize data. So this thing called ggplot, which may not mean anything to you now, but in a couple of modules, you'll see how it can be used to visually summarize data. The tidyverse is kind of the workhorse of a lot of data cleaning and analysis and visualization in R. And we'll talk about it a little bit more at the end of today's session as well. Rio is incredibly useful for importing and exporting data sets. We'll touch on this in the next, I believe, the next module, where you actually learn, because so far we've worked in R, we've coded, but we haven't actually worked with any data. And you can imagine, especially if you're working at a hospital, you have clinical records, you have large Excel sheets, but then how do you actually get those Excel sheets into R and work with them? Rio is a great package that enables that. Here is a package that helps you organize file paths. So I believe we'll also see this in future modules. Often health workers work with multiple data sets. So you have a data set from your emergency room, maybe a separate data set for inpatients, a pharmacy data set, and they live in different places. So here actually helps you kind of connect to those and make file organization a lot easier, which will make more sense in practice. Janitor, so in addition to tidyverse, Janitor is quite useful for data cleaning. There's lubridate, which is useful for working with date type objects in R. So remember, of the different object classes, date was one of them. And you can actually do a lot of cool things with dates. You can kind of make analyses periodic based on date variables. You can say for every month, I want you to calculate this, which you can imagine is quite useful in healthcare. You know, if you want to see disease trends and patterns over time, you can summarize by month or whatever your time variable is. There's also string R, which is good for working with character type objects. This I've seen quite used in working with, often in healthcare data sets, you have variables for names, hospital name, name of location or city. So it's quite useful for working with those objects. SCIM-R, so the rest of these, the bottom four, are very, very useful for summarizing data. So SCIM-R provides overviews of the data set. GT summary helps print out summary statistics and basic statistical tests. So you can run one small function and it'll print out a really nice looking table, which we will see in future modules. RStatic does a very similar thing, and then Flex table also is often used for publication. So it creates very, very high quality tables. But again, don't worry about memorizing this. I'm just mentioning it now so that it's kind of floating in your brain, and when you see it later on, then you might recall. But these are the list of pretty heavily used packages in R. I told you to keep tidyverse in mind. I'm going to take a moment to talk about base R versus tidyverse. So before I hop into that, can anyone tell me what base R is? So if you remember from earlier today, what do I mean when I say base R? You can either unmute or type in the chat. The packages that come with R Studio, basic packages when, okay, fantastic, exactly. So base R is all the packages that come with R Studio, so they're found when one installs R. And then tidyverse is a package that I have now installed. The reason I'm telling you about base R versus tidyverse, so I mentioned that tidyverse is kind of the mother of data analysis. It also comes with its own coding conventions. You can think about it as like a different dialect of the language. So if R is the language, base R is one way of coding. Tidyverse is a slightly different dialect. That is worth learning because it's often cleaner or easier to read than base R is. I will illustrate this in a moment. You can see the difference. So over here, as we said before, tidyverse is like a package of packages designed specifically for working with data in a tidy way. But you can do almost everything without it. That's a different way of doing it. So there's the base R way of doing it, and then there's a tidyverse way of doing it. And I will go through a quick example to illustrate the difference. So this is obviously very fictional code. You can produce music with R, but you cannot bake a cake with R. At the top here, we're showing what the coding convention or the dialect is if you're using base R. So you kind of work from inside outside. You can see the most inside brackets are combined flour, egg, baking soda, butter, and sugar. Then you move one bracket out, mix all ingredients together into a cake batter, and then you move another one out, put in oven. So it's kind of nested like that. You start from the very inside and you move outside. And then the tidyverse way of doing it is more stepwise. You can see the code actually takes up more space. It looks longer, but it says I start with flour, then I add my egg, and then I add baking soda, then butter, then sugar. And I mix all of my ingredients into a cake batter, and then I put it in the oven. And this little weird % thing is called a pipe operator. We'll, I think, talk about it yep, we'll talk about it in the next slide. But you can think of it as just joining these steps together. So there isn't one way isn't necessarily the right way of doing it. These are both two different ways that accomplish the same task. But you can see that they do look very different from each other. But you might prefer one over the other. We're going to teach you both. But you'll see when we get to more data analysis heavy and visualization heavy tasks, we tend to focus more on tidyverse, just because it is easier to read. You can see this only has 3 brackets, but you can now imagine if I went to do like a 20-step operation, reading into 20 nested brackets gets a little bit messy. And often you aren't the only one working on your codes. Whatever I code, Duncan has to read, or whatever Duncan codes, Frank has to read. So doing it step by step, even though it takes more space, is often a cleaner way to code and an easier way for other people to actually read what you're doing. So over here, what we're showing in the slide are 2 different ways to code. So both of these are ways to code in R. Base R means I'm coding without any additional packages installed. Tidyverse is a collection of packages itself that has kind of its own dialect of coding. So you can even think about it as if I speak a language and there's 2 different dialects, I can read both dialects, but they both have slightly different words, slightly different sentence structures, but they both accomplish the same task. So over here, the first one, this one is base R. So base R dialect or base R coding convention, you tend to perform operations in a nested way. You start off with the most inner operation, combining flour, egg, baking soda, and sugar. Then you mix all those ingredients into a cake batter, and then you put that in the oven. So it's very nested like that, and all of the steps kind of go from inside to outside. Whereas in tidyverse, which is what you see on the bottom of the slide, you, instead of going from inside to outside, you go top to bottom. You start with your first step, move on to your second step, third step, etc. You kind of think of each line performs its own thing, and then it happens in that order. Whereas base R, it kind of happens all at the same time, but you work from inside to outside to understand what happens first, if that makes sense. We'll see it, maybe an example might make it easier. Actually, yeah, we'll go over this data set in a moment, and perhaps that might make it a little bit easier to understand. Okay, nice. So over here, I talked about this weird looking thing over here in the previous slide is called the pipe operator. Truly, I'm not sure why it's called a pipe operator, but it basically, the function that it performs is passing some output, intermediate output from one line onto the next. I like to think of it as saying and then. So in the previous slide, I can say I start with flour and then I add egg and then I add baking soda and then etc. So it's a good way of just linking different things that are happening in your code. And many different functions or steps can be linked together with a pipe operator. Piping usually emphasizes that a sequence of actions is happening. And pipes themselves, you don't have to worry about this. They come from its own package, which exists within the tidyverse. But basically, they exist because they can make code look more clean, and easier to read and more intuitive. So it really helps you organize the code. And we'll see it in an example in a moment. Oh yeah, this is a question for you guys now. Given what you have learned in the last couple of slides, do you, off the bat, do you prefer base R or tidyverse? There's no right answer. I will not hate you if you like base R better because I also use the code in base R. If there's any strong opinions, one way or the other. Oh, we have some tidyverse fans. Great, great. But again, base R fans, I understand. It's also
So,
a good way to code. Oh yes,
so maybe,
Duncan, go ahead.
Ashna, maybe one of them can tell us why they think that tidyverse, or why they're choosing tidyverse in that case.
Yeah,
Uh,
it's a good idea.
maybe Simon, Chioma, Onyinye, or Nura, any of you?
I
Or
think Chioma raised,
okay,
oh, two people raised their hand.
okay, let's hear from them.
Yeah, Chioma and Simon. So maybe
Evening.
Chioma first and then Simon.
Evening. Yeah, I think
Good
I
evening.
prefer tidyverse because it looks more organized. The base R has so many brackets. I feel like I might lose count when I'm trying to code. I don't know how many brackets are remaining before I end the code. Like I feel like I might get confused. Tidyverse looks more organized and it makes like it just looks really neat. So I don't think I will get confused coding with tidyverse as a newbie. Maybe well advanced and I can now try base R, but as a newbie, I think I would rather go for tidyverse.
Good answer. What about Simon?
Yeah, I would also opt for tidyverse because, as you said, it's the packages of packages. But at the end of the day, I like my things to be systematic. So I rather opt for something that makes it easier and also makes it something that I can just go through and find like, my work is arranged better. So the arrangement, the sequence of tidyverse, allowing the piping, allowing to connect things, that made me to choose tidyverse. And it has multiple functions. So I'll literally stick with tidyverse.
Nice. I am convinced you guys have both hopefully converted anybody out there using base R. And I see Duncan's also provided. There is a keyboard shortcut for this type operator. You can press Control Shift M. Or if you're a monster like me, I do it by hand every time, which I should really get into the keyboard shortcuts. But there, okay. We have our answer. People are tidyverse fans. Fantastic. So right now what we're gonna do is we will go over a quick example of using, installing a package, using a function from it all at the same time. This is also included in your online module, so don't worry about kind of fumbling to follow along now. You can either watch me do it, or if you'd prefer, to open up R in RStudio or RStudio on your side and try it, feel free. Oh yeah, and here, you can see my infinite code or infinite comments. There we go. Aha. So over here, this is kind of, I'm explaining this sort of conventional sequence of things that happen in your code. The first thing in your code, actually, we're going to improve this. The first thing in your code, like any other document, should always, oh, I heard somebody. Hopefully all is okay. The first thing in your coding document should always be a title. So this goes for any document you write. I've got a very uninformative title now, so I'm going to change that. I'm going to say module 3 coding example. I'm going to say it's going to be last modified on 31st October 2024. Last modified by me. Go over here, you can even, you can get a little bit fancy. A lot of my codes have random and unnecessary little things here to make it very clear that this is a header. But basically the point is you should have an informative header over here The reason being, as I said, you will very rarely be working on a coding document on your own. Chances are you are going to be collaborating with somebody. So it's very good to keep track of who modified the code last and when they modified it. This can help just keep track of different versions that are floating around. I think in a future module, we're going to introduce GitHub, which is also a handy way for tracking, doing version control and making sure people have the latest and greatest version of everything. But for good practice, you should always start with an informative header. Then typically, the next step in your code is loading packages. It's always important that you install and load packages at the very beginning because any function that you want to use from those packages happens later on in your code, right? So you have to first install packages and load them in order to be able to use those functions. So over here, this is prompting me to install Pacman if I haven't already. If I've installed it already, you can just put a hashtag in front of this. So I'm going to do that. I already have Pacman installed. So I will put a little hashtag in front and now you can see it's grayed out. So now it's become a comment. And you can see also there's a lot of gray in this. A lot of gray is good, or I mean, if your RStudio might actually look different from mine. Maybe it's worth showing. I think Frank might have showed this in the first class, but in case you missed it, you can change how your RStudio looks by going to Tools, Global Options, and Appearance. So mine, the theme is called Chaos, but I can also change what it looks like here. But basically your code should have a lot of comments in it because comments are explaining kind of why I'm coding the way I'm coding. It's explaining what each step does. You can choose to be more detailed if you want. You usually don't have to be as detailed as I am in this example, but it's good to more detail is always better than less detail. So over here, I've commented out install.packages because I already have Pacman, but I think you might not have it. So on your end, it'll be important to install Pacman. Once it's installed, now I can use it to load and install everything else. Now I'm loading a package called dplyr. And if you remember p_load, we'll go ahead and install dplyr if you haven't already installed it. If you have already installed it, it'll just load it for use. So I'm going to go ahead and run that over here. You can see down here, it has run, no errors. The reason we loaded dplyr is because for this example, we're going to be using the Star Wars dataset, which is available within that package. The first function we'll use is this view function. It's a very handy function to just take a look at the dataset. So if I say view Star Wars, and I run that, it's going to open up the data set here. If you are a Star Wars fan, you might understand this data set a lot better than me. But as far as I can understand, it has information on different characters within the Star Wars universe. Specifically, it has information on how many characters did it? 87. So it has information on their height, weight, hair color, skin color, eye color, birth year, sex, gender, homeworld, species, and films that they were in, vehicles, whether they have any vehicles, starships, and that's it. So it's a pretty detailed data set. And it's kind of good to use for illustrating different examples, which is why I'm using it right now. So over here, I am now using some tidyverse conventions. Don't worry if you don't understand this fully now. When we start working more with data, you'll get used to how tidyverse works. This function is counting how many characters have each type of eye color. So over here, the way it works is it's taking my data set, Star Wars. So I'm saying I'm starting with Star Wars, and then I'm counting eye color. So when I run this, it prints out a table looking like this. Now I can see 10 characters have black eye color, 19 have blue, 21 have brown. You can see this. But suppose, what if I want to add something to this? You can see this table is kind of out of order, right? What if I want it to display the most popular eye colors at the top and the least popular at the bottom? I can add to this. I can do, or here, I'm gonna put this on another line so it's looking tidier. I can say arrange minus descend in descending order by the variable n. Now if I run it, it should now show the most popular one at the top and then in descending order go down here. So this just goes to show that in tidyverse, I can now, these are two separate functions. Count and arrange are two different functions, but I've strung them together using this pipe operator to count how many different characters have each type of eye color. That's a really simple one, but you can see when you get to more complicated data cleaning tasks, you often have many lines with many pipe operators in between, stringing them together. And the last little bit now shows another handy function within dplyr. The dplyr is a tidyverse package. It's called filter. The function number 3 shows it's filtering the data set such that I only have observations for characters with hazel eyes. So here, I can also put enter to make it look more clean. So I say, start with my Star Wars data set. I'm going to filter those characters where eye color equals equals. So why do I have a double equals here? I have a double equals because a single equals works kind of like the arrow. So a single equals will kind of look for assigning a value rather than actually checking if something is equivalent. So the double equals checks if something is equivalent. So for here, it's going to check for characters where the eye color is equivalent to hazel. And prints out. You can see over here, it hasn't really printed out all of them. So what I can do is I can create another data set called Star Wars Hazel Eyes and say this. Now I'm creating an object called Star Wars Hazel Eyes. I'm assigning to it a data set wherein I have started with this big data set called Star Wars, and then I have filtered for hazel eyes. So if I press enter on that, you can see now in my environment pane, we have a data set called Star Wars. And again, I can either click on it or I can say view Star Wars hazel eyes. If I run that, it shows me 3 characters for eye color is hazel. And I now have the data set for subset for defense. And suppose I wanted to filter by other things. If I wanted to now say height should be above 175, or let's say birth year, what's another thing? Yeah, we'll say height. Now we can say filter height bigger than 175. Now we can only see this one person who's taller than 175. They've been included in this data set. But again, this shows how I'm stringing different steps together. I'm going to pause there for a second to see if there's any questions related to this, or if there's anything folks would like to try with the Star Wars data set. We can give it a try here together. No questions? Okay. Cool. Then we can maybe do a quick review of what we've gone over today. Oh, Chioma has a hand. Yes, go for it.
Sorry, could you explain the last function again? I didn't really understand.
The
last
filter or
function.
view?
From the beginning, actually, from the beginning of that function, that entire
This.
function 3.
Okie doke. Yes, I can.
Thank you.
So here what we're doing is we're using a function called filter. So filter is a function that exists within a package called dplyr, which we installed and loaded here. What filter does is it filters your data set based on a certain condition. So you can imagine if I have a big hospital data set and I only want to look at pediatric patients, I'd want to filter that data set or only pull out the patients that are under 18 years old. So this function helps do that. So in this example, what I'm doing is I am reaching into the Star Wars data set, that's the main data set, and I'm saying I want to filter all of the characters where eye color is hazel. I use this double equal sign to look for matches. So this will go through eye color and look for eye colors that match the word hazel. And then I'm also saying now I also want to filter, or now I also want to pull out characters where the height is bigger than 175. So in my data set over here, and what I'm doing here is I'm assigning it to a separate object. So I'm creating an object, or I'm creating a data set called Star Wars Hazel Eyes, and now I'm assigning it to it, this over here, this filtered Star Wars data set. So what this is going to do is it'll reach into Star Wars, it'll find characters that match my conditions. So my conditions are that eye color has to be hazel and height has to be above 175. And it's going to add those characters to this data set. And you can see the data set here. Indeed, it has found one character where the height is above 175 and the eye color is hazel. So that's what it's doing here. And then finally this view, just if I run this, all it'll do is it'll open up this data set. So you'll see this in more examples at the end. And we see another comment, somebody, how do you learn and keep track of all these functions? And Duncan answered it correctly. So over here, the main idea is that the functions help you achieve your end goal, and there's no way you can keep track of all of them. So that's why Googling is very, very useful. So I can even say, how do I, or say filtering data set in R. So it gives me a few different options. And you can see one of them is dplyr, keep rows that match a condition. So hopefully that answers your question, Timo. I see there's another question. What is the difference between equals equals and the little arrow sign? So the arrow sign assigns a value. So over here, I'm creating an object and assigning it a value apple. Now, the double equal sign looks for a match. So if I say A equals apple, it'll tell me whether the word apple, a match for the word apple, is found within the object A. So if I run this, it's going to say true, because indeed A is exactly equal to apple. That's the difference between these two. And yes, I see Duncan has answered Simon's question. Star Wars does exist within dplyr. So if you want to try it on your end, I do encourage you to try installing and loading the dplyr package, and then you can play with the Star Wars function. You can try out these different functions over here, count, arrange, filter, and play with the Star Wars dataset. Can someone explain what this is? One that I just highlighted. You can either raise your hand. So I want you to explain what it is and kind of what it's used for. You can use the examples on the screen here if you'd like. Yep, I see people are saying it's pipe operator. It's used for joining one action to the subsequent one. That is exactly correct. So you'll see this more and more in future modules. It's just used kind of for stringing actions together. So it's very well used. Just to recap what we did today. So folks remember for the module kind of quiz and homework is we talked about functions and how functions are typically structured in R. We also talked about what packages were and the difference between base packages versus those you have to install. We then talked about a few different ways to install packages. Now that you've seen these different ways, you can kind of pick whichever one you think you like best. So there's the install.packages way, where you install a single package and then you load it using library. There's one way to load packages and use them at the same time with the double colon. And then finally, there's the pload function within the pacman package, which checks if you need to install a package. If you do, it'll install it for you, and then it'll load it for use. We also took a look at how to find out more information. So I'll keep stressing it. Do use Google, take advantage. And these are some helpful packages. Don't worry about memorizing these. You will see these come up later on in the course. We then talked about base R versus tidyverse and how these are two different coding conventions or ways to code. This example kind of illustrated the difference between them, where tidyverse approaches things sequentially, whereas base R approaches things in a nested way. Then we talked about the type operator finally. And that was, so there's not a lot of content for today's session. It was mostly to introduce these concepts. So everything you've kind of learned in the past 3 sessions, starting next session onwards, a lot of it will be application based. So you'll kind of have to learn how to use, we got a taste of it today in the example, but you'll learn different ways of using a lot of these functions and packages and how to proceed with that. So I know we only have a few minutes left. Maybe I can take a few minutes then to quickly show you how you might use ChatGPT to help with coding. So over here, suppose I want ChatGPT to, and this is, again, it's a very valid way to start a code. People can obviously use ChatGPT to print out the answers for things, but one really good thing that ChatGPT does is it explains code. So if you're really stuck on something and you don't know how to approach it, I can ask, like if I say, how do I import a data set into R? And it actually prints out very, very helpful examples over here. And it'll show different types of files. We have CSV, Excel, text using R's built-in data set from a data, like you can see it's now showing me a whole bunch of different options. And it's a very, very helpful and handy way to actually start coding. So if you're ever stuck, ChatGPT is a very, very valid option to help you find your way, because it does have really good summaries. And of course, you have to take it, all of this with a grain of salt. On the back end, ChatGPT is trained based on all of these links like this, which may not, a lot of these are blogs, which may not always have the best answer. So you do have to be a little bit critical of ChatGPT sometimes, but for a lot of the tasks we'll be doing, they're not complex enough that ChatGPT will get confused. So hopefully it'll be useful. But I'll pause there. If there's any remaining questions, we can chat about it now. And if not, I'll maybe hand it over back to Duncan.
Okay, thank you so much, Ashna, our facilitator for the day. So
No problem.
I don't know whether there's any burning question, because we have a few minutes left for today's session. What I'd like to say, and I'll be speaking on behalf of the panelists, is that let us keep these discussions going on. If you have any question or any comment or any clarification that you are seeking, please let's engage on our Afredac page. There's a discussion tab there. You can post any question, and you can post any questions that you have, and we'll be glad to answer. And let us continue creating this community, and we develop this capacity for our coding.